So I want to talk about hydrogen mobility, and to motivate that, I have to speak about the renewable energies. I looked at the program and see that in the next few days, you have a few things ahead of you about wind energy, about solar energy, but I'm the head of the Institute for Renewable Energy Systems. So we have to understand that what in Germany is called the Energiewende, yes? So we are doing this turnaround in our energy supply, going away from fossil energies now to renewable energies, that this is not just about wind. It's not just about solar energy. It's about the entire system. And mobility is one big part of that system. But to talk about mobility, we first have to look at this renewable energy system. And since I cannot welcome you today here in Stralsund at our laboratory, I want to explain the system and at the same time show you a few of the things that we have in our lab. So first of all, of course, we need a wind power plant, we need a solar array to produce the renewable electricity. And so once we have that, once we have renewable energy, and you see here these installations that we have at our campus, we have our own wind power plant, we have our own PV installation, we're thinking about bigger PV installations now. Once we have that electricity, that is now volatile, right? It's fluctuating, we have a lot of wind, we have a lot of sun at certain times, and at other times we have almost no wind, and that there is no sun in the night is nothing new. So we have to store the energy, or we have to use it when it is available. And the way to use and store energy is an electrolyzer. So the electrolyzer splits the water molecules H2O into these two components, so into hydrogen and oxygen. And you see here the hydrogen arrow, the red arrow. Let me see if I get laser pointer. There you go. The hydrogen arrow here then needs to go into a storage. The oxygen arrow, that goes into the roof. So oxygen from our electrolyzer just goes into the air. Of course, you can find some solutions on how to use the oxygen, but mostly this is too expensive. So mostly the hydrogen is used and the oxygen is released into the air. And then the question is, how can we store hydrogen? I will come back to that in a bit later. Here, our electrolyzer that is seen in this picture stores our hydrogen in this simple steel cylinder tank. So no complicated storage mechanisms, just a steel cylinder, 30 bars of hydrogen pressure that come directly out of the electrolyzer, and that's it. And then we can use the hydrogen. And we can use the hydrogen in several ways. The one we want to talk about today in this presentation is mobility. So we have our own hydrogen filling station. You see here our filling station. We can give hydrogen at a pressure of 350 bars. That is not the pressure that is nowadays used in cars, but nonetheless, we can fill a normal hydrogen car half full. Okay, we cannot fill it completely because we do not have these 700 bar, but we can still fill it halfway up. And what is also important to note are these years always, right? We are talking about 2013. That is, well, soon to be 10 years ago. So almost 10 years ago, we already had our own, it's not our hydrogen car, but we had our own hydrogen filling station, and we filled a hydrogen car with that. The hydrogen has many more applications, and that's why the hydrogen is so important for this renewable energy system. Of course, a fuel cell, in German then Brennstoffzelle, fuel cell is the most efficient way to convert the hydrogen back to electricity. A fuel cell is used in such fuel cell cars. That's why they are so efficient. But fuel cells can also be used to create electricity for homes, can be used to create heat for homes. But hydrogen can also be used in many other applications. We have a normal engine here. This is an engine also from our lab. All these pictures are taken from our laboratory and showing the different applications. So we have here a normal auto engine that can use hydrogen. Okay, so we can produce, of course, again, electricity, electrical energy. We can produce heat. And if we oxidize the hydrogen back to our input, water, of course, water is the output again. We can also just go for heat, okay, without any electricity production. We can go here with this catalytic burner to a heating solution, all just based on hydrogen, all of that based on the idea that the hydrogen is the storage solution for our renewable energy system. Today, we want to talk about mobility. Our own mobility solution is this Tiger race car, and I want to, if we have the time in the end, also give you a few insights into that project. So in the end, this is our hydrogen circle. Okay, the hydrogen circle starting with electrical energies from renewable sources and in the end going back to electrical energy. However, we fulfill many criteria on the way. So we have fulfilled mobility, we have fulfilled energy storage or heat supply in the midst of winter. Many things that you cannot do with the direct use of the electricity, but we have to pay with a deficit in the efficiency. So from the electricity that we put in here, we only get 1/3 of the electricity after the entire hydrogen cycle. So we have to use the other parts of it. We have to use them, as I said, for mobility or other solutions. This is something that, well, kind of was invented here in Stralsund. So this was already implemented in the year 1996. And for many years, colleague Lustinets, whom you see down here in a picture, has been leading the institute. And his predecessor, Professor Lehmann, he invented in the early 90s this hydrogen loop. He said, if we have the renewable energies from wind, we need to store this energy in hydrogen. Other people have also come up with that idea, and now everyone agrees that this is the main solution to which we should all go to. And that's why I like to show this slide as well, to give you like an official graphic on the mobility, on this hydrogen solution. So not something that I came up with, but something that other people. So the German strategy platform Power to Gas, that's what it is called now in the political talk, Power to Gas. In this, all of this Power to X and Power to Hydrogen, as I like to call it, and then Hydrogen to X. And so they have this official slide here in a Deutsche Netzagentur. So the German grid agency has this slide, which is very similar to what I just showed, right? We have fluctuating renewable energy sources. And the key part is the electrolyzer, the electrolysis that produces hydrogen. And hydrogen can be used, and that is in addition to what I just said, not only in mobility, electricity production and heat, but hydrogen can also be used in industry directly. We use already today in the industry many, many tons of hydrogen. And that hydrogen mainly comes from natural gas. We use hydrogen in the oil refineries, we use hydrogen in the ammonia production for fertilizers, we use hydrogen in many, many chemical applications. And most of that hydrogen comes from the methane from the natural gas. We have a big methane grid. This is what's called here Erdgasnetz, right? That is our big methane grid that we have here in Europe. That is working very well. And so one proposal is to use the hydrogen that we are producing from renewable energy sources and use this hydrogen through either a process that is creating CH4 again, methane from the hydrogen, or use the hydrogen directly in the gas grid. So these two options exist. Use the hydrogen directly in the grid, or first of all, go through one more step to create methane. And then we have what's called synthetic natural gas. It has the advantage that we can use our old grid for a long, long time. So we have already this big grid and we can keep using it. And you see that even with the natural gas, we can fulfill all these different, and in general, there should be also an arrow pointing here because natural gas is producing hydrogen that then goes again into the industrial use. This only makes sense if we substituted all of that already. Okay, so we should probably not produce methane from hydrogen and then produce hydrogen from methane again. So we can already drive cars nowadays with methane, and that is a lot more common in the rest of the world compared to Germany. In Germany, it is not so common to use natural gas cars. In the rest of the world, that is more common. But we don't want to talk about natural gas cars. We want to talk about hydrogen cars. So let's compare the hydrogen car maybe with the biggest other solution that is out there, and that is the electric car, the battery electric car. And we have to distinguish here because a hydrogen car is also an electric car. The battery electric car and the hydrogen electric car, fuel cell electric, and we will put all of that in one slide together as well. We have here on that slide the needed space and the needed volume in a car to drive 500 kilometers. So how much space in my car do I need to drive 500 kilometers, and how much weight do I need in my car to drive 500 kilometers? And we see that the best solution is just using gasoline, is just using diesel oil. So then we need about 33 kilograms of diesel, and with that we can drive 500 kilometers. We need about 37 liters. So if you are driving your own cars, you can find out that these 500 kilometers on 37 liters is actually pretty optimistic, but okay. The advantage of using diesel is you only need a few more liters for the system. And so here you always see the colored number for the actual energy carrier and the black number for the system. So a diesel tank system consists out of 37 liters of diesel and a few more volume, just 10 more liters of the gasoline, pipes, and the area around or the tank itself. And all of that weighs about 10 kilograms. So a normal conventional car can, with about 50 kilograms and 50 liters of volume in the car, drive 500 kilometers. That is nice. So if we go to hydrogen, we can use these 6 kilograms of hydrogen to drive 500 kilometers. 6 kilograms of hydrogen are enough with a normal fuel cell car nowadays to drive 500 kilometers, and fuel cell cars are available and they prove this number. However, hydrogen being one of the lightest elements, or the lightest element, needs to be compressed, and it is compressed in the cars to 700 bar. That is really high pressure, and this high pressure vessel, so it now is a storage tank, this high pressure vessel needs way more weight than the 6 kilograms. And in our lab, we have such tanks, and if you at some stage visit us, and I hereby want to invite every one of you, please contact us, come by if you're near here, or if you're traveling through Germany at another time as well, later in your life, just come by and say, look, you invited us many years ago maybe, and now I want to pick up such a tank, or maybe they have become lighter, or maybe in your later research life, you do something especially in this direction, and then you can please contact us and say, look, I've invented a new tank that is a lot lighter. We have such tanks, and you could lift them and you feel the weight, they are heavy. And so to store 6 kilograms of hydrogen, you need 125 kilograms of the system. The volume is also difficult. These 6 kilograms, even though they have been compressed to 700 bar, still need 170 liters in your car. Since these tanks are round, you cannot put them into nice little corners. You have to lose a lot of volume in your car. 260 liters of volume are lost in your car. So if we compare that to diesel, this is a big step. This is huge. Weight does not play such an important role. Weight is important, but it's not the most important role, but volume is important. And we will talk about that later more. People do not accept that in their cars there is volume for the energy storage. Okay, everyone expects their car to be for them. Because I want to transport something from the hardware shop. I want to transport wood. I want to transport stones. I want to transport my luggage for my holidays, right? That's what I want to transport, not the energy. We have been so accustomed to this comfortable solution with the diesel that we feel very much a discomfort if we go to a solution like this. And now if we compare that to the lithium-ion solution, to the battery solution, you can find out that the batteries themselves weigh almost a ton. I mean, here it's 830 kilograms, and they take up a volume of 670 liters. So even more. We have to be a bit honest, and normally I don't like to keep such old numbers here on the slides, right? Because 2008, that's many years ago. But if you compare the numbers for the batteries, they have not become much better. They have become better, yes, if we are really honest and we look up really actual numbers, then the batteries have become slightly better. However, the battery electric approach promises since many years, and you see these numbers from 2008 still, right, are still holding up. They have been promising for many years that the batteries will keep developing and the batteries become better, but they have not. They have become better. Yes, they have become slightly lighter. They have become slightly smaller. They have become slightly safer. But batteries will never reach these numbers. And you can see there's a factor of more than 5 in between. And this is not possible with whatever solution you have. Oh yeah, okay, that's a good question. How's the system weight compared? Yes, the diesel engine has about the same volume and weight as the fuel cell from this one here. So weight and volume are very similar between these two. The battery electric one needs smaller motors, the electric motors, they are again here as well. So we need the electric motors, and they can be smaller here in this one, and they are also lighter. So you save a bit of weight, that's true, by using the electric motors compared to here having the big engine in the car. That is absolutely true. So if we look at a slide here that shows these energy densities, and we're looking here at the energy density volumetric and gravimetric, meaning how much energy do I put in 1 liter into 1 volume, and how much does this weigh? Of course, if we weigh things here, hydrogen is the lightest gas, has basically no weight. So does natural gas, right? But still the weight is a lot higher. But we do not get much energy into our volume. In our car, we don't want to have a big balloon over the car. We need to put the hydrogen into the car, so we need to compress it. But even compressing the hydrogen, we get only up to here, 700 bar. So the volume is still bad, and we just saw that. So now if we look at different other parts here, let's orient ourselves in this chart. We can find here gasoline and diesel, kerosene. So right here in the center, really low, and low is bad in this case, right? Low compared to hydrogen, gravimetric density, but pretty high compared to hydrogen, volumetric density. And here, why is hydrogen so good on the gravimetric density? Well, as I said, it's so light and it's not the system here, okay? Here it's really only the energy carrier, and that's why we have here only the very high numbers compared to the others here. So what are other solutions? And I will come back to them later as well. There is, for example, ammonia, there is methanol. Right now, a lot of discussion is about liquid natural gas, so LNG is in the discussion, but you see none of them is even close to that. So what would be better is something like lithium borohydride, also some stuff that you really don't want to have in your car. It's really not healthy, okay? And it's also not sustainable to use it because it's not something that you can recharge, okay? It has energy, a lot of energy, but it's not easy to get that energy out of that. So the question always is, how do you get the energy out? And so let's find on that chart the batteries. Lithium-ion batteries are somewhere, yeah, down there, right in the corner. The batteries are a very nice solution. If we compare that in the cars here, in the complexity and so on, then the battery electric vehicle is a very nice solution. It is actually a very old solution, right? Battery electric vehicles have been invented in the last century. Talking about 2000 now, in the century before that. So the first battery electric vehicles have been driving around in 1890, and because it was so simple, right? An electric motor is a lot easier. But since then, the batteries have been developing, but not so far as to actually be good enough for our energy demands. Let's talk about that. Here in the middle, the most simple one, we have the BEV, battery electric vehicle. This is, as you can see, the least amount of parts. So you have your battery system, you have your charger. That is also a big thing. How do you charge your car? How quickly do you get the energy in there? How long are you able to wait? Then you have some power electronics. You have your electric motor, maybe a transmission. Even nowadays, you don't have transmission anymore. Sometimes the motors are directly in the wheels or on the axle, and then you have a very lean solution. And that's good, right? In technology, it's always good if something is lean. Don't make things more complicated than they have to be. However, if it does not fulfill the need, then we have to make it more complicated. And the need really is to drive long distances and to recharge the car in a short time. At least right now, that is the need. And we want to be honest here, right? We think that we will drive in the same way as we do right now. However, with the now upcoming autonomous driving, where depending on whom you ask, this either comes in the next decade or in the next century. So people are not really too optimistic about autonomous driving. But if the autonomous driving is coming, it will change our mobility behavior in a way that we cannot even imagine right now. So the system that we have right now, where everyone is able to jump in their car and drive 600 kilometers, and on the way just maybe recharge their diesel tank within 5 minutes and then drive 600 kilometers again. This system will not be the system of the future. We will have different systems. And either people are willing to accept that for their individual mobility, using a battery electric vehicle, it is totally okay to drive a certain distance. We will see how far the battery development will go, maybe 300, 400 kilometers, and then charge their car for half an hour. It probably is a good idea to take half an hour of a break after driving for 300 kilometers, but for hectic people, that's not good. For people in the business, it's not good, because if you drive long distances, me, for example, I need to drive across our big state of Mecklenburg-Vorpommern, and I need to go to Schwerin, our our capital here. Need to speak to politicians. They don't have much time. I don't have much time. So I drive there, then we have half an hour of a talk, and then I have to drive back. And that's more than 300 kilometers. This is not possible now with an electric car, battery electric car. And so there are many applications that you can think of where a battery electric car is not capable of the need that we have now. But if we are optimistic, and from the other side, you can say there are a lot, and even more probably, solutions where a battery electric car or vehicle is totally sufficient. Having a small car in a town, it's totally okay to have a battery electric car. You only drive short distances, the car is standing the entire night, and then you're just going on a short shopping trip. Then a battery electric vehicle is totally fine. Well, you need to have a charging station close to your house, right? Because otherwise it becomes complicated. Whose electricity are you using and who's paying the bill? So if you have your own private house, that's no problem. If you are in the city and you have these little two-wheeled motor vehicles, motorbikes, and you're driving shorter distances, then of course battery electric solutions are also totally fine. So for everything that is a scooter, that is a somewhere above pedelec and below a motorcycle, anywhere in there, battery electric solutions are very nice. Now, if we want to think bigger, and we need to think bigger, because if we drive a bigger car, if we drive a truck, if we drive a train, maybe even a ship, we need to think bigger. These mobility solutions will not be done by battery electric vehicles. This does not work. So this battery electric vehicle works nice for a little scooter, for a small car in a town. For everything else, we will need these fuel cell electric vehicles. And we can see it's an electric vehicle because it also has a transmission, electrical motor, and power electronics. It also has a battery, a small battery, similar to the batteries that we have in our cars now, that are a starting battery. Maybe with the newer ones you can drive for a shorter distance. And then you have your hydrogen tanks, and you have a small balance of plant part where you have your charger, so where your hydrogen is filled into the car. You also need to look at the temperatures and things like that. So it is a more complicated system. And here you have your fuel cell stack inside as well. The other solution, which I really do not like right now, is this plug-in hybrid electric vehicles. These are in the discussion now, and this is something where you put the worst of both worlds together, and the German government is funding these cars like crazy, and the German car industry is happy because they can sell even more stuff, right? They can sell their internal combustion engines, they can sell the cars, they can learn how to use an electrical motor, they can also sell batteries and the charger and everything, and they can sell very complicated cars that are very heavy and have a way too small engine, way too small tank actually for what they really need to do. Anyway, this is something that hopefully disappears sooner or later. It has, however, an interesting future option, and that is, here you have a generator, you have what's called range extender. This entire white branch is the range extender to your battery electric vehicle. And such a range extender can also be hydrogen based. It does not need to be based on an internal combustion engine and on fossil fuel, but you can include, and basically it's seen over here as well, this range extender, because you can drive short distance in a battery, and then for longer distances, you can use your hydrogen. So we have to distinguish between the old cars. This is the internal combustion engine cars. Then you have the battery electric vehicles, and we discussed the plug-in hybrid electric vehicles, and then you have the fuel cell electric vehicles. Maybe for those who have never seen a fuel cell before, let's talk about the processes that are happening in there in such a fuel cell. And again, something with a very old graphic and with a very old year number in the corner of the slide. But this is supposed to show that this is no new technology. This is not something that I invented yesterday in my lab and it's now soon to be working. No, we know how fuel cells work since a very long time already. So we need to talk about the processes that are happening here inside the fuel cell. From one side, we have the hydrogen coming towards the fuel cell. And from the other side, we have the hydrogen coming. The oxygen, sorry. We have the oxygen from one side, and from the other side, we have the hydrogen coming here. And now we have in the middle a membrane. And this membrane only lets the protons through. You see this here, that our hydrogen, that is a molecule on the left, kind of becomes atoms through a catalyst, and then is even split into its atomic parts, the protons that go through the membranes and the electrons that are not allowed or that cannot go through the membrane. So the electrons go all the way around, and if electrons go somewhere around, they are an electrical current. So we can use this current here in this part. It's to show to have light, and of course we can drive an electrical engine with that. And then the electrons come here, the protons come from there, the oxygen comes from there, and we get water again. The efficiency of such a fuel cell is roughly 30 to 50%, or we should rather say 50 to 30%. The fuel cell has one big advantage. It is more efficient in partial loads. And most of the time, if we sit in a car, we are only using part of the power that we actually have under the hood. I mean, depends on how you drive, right? But if I drive, normally I'm not putting the pedal to the ground all the time and do not drive full power. So I'm normally not taking the entire power from my engine. A normal engine, a normal internal combustion engine, is less efficient if we only drive it in partial power. It's most efficient at high powers. So a fuel cell is actually a perfect solution for that, and is really the mobility a good application for fuel cell technology. The fuel cell has an efficiency of about 50 to 30%. The electrolyzer before that to produce the hydrogen, and that is one of the questions here, right? The electrolyzer has a efficiency of 75%. So the overall efficiency, electrical energy to electrical energy through electrolyzer fuel cell, is about 30%. So we need to apply that really only in case we have either no other electricity available, or we have a very high investment solution for the electricity, and that is driving a car, right? We pay a lot of money to drive our cars, and we are very happy when we drive our cars, so we pay a lot of money for that. So hydrogen as a solution for mobility is just great, but it only works if we have green hydrogen. And this green hydrogen needs to come from renewable energy sources, from wind and solar. And the other part of the question here was, why does this not attract more investors? Well, because the hydrogen system is very complicated in its entire system. And you need so many players. You need the one that's producing the electricity, that is wind and solar. you need the one that's producing the hydrogen, and you need the one that's using the hydrogen. So 3 different players, and maybe someone needs to store the hydrogen and distribute it, and then it becomes even more complicated. If you put all of these players into one person, that is possible, but it costs costs a lot of money. So you want to distribute that. However, none of these 3 players will make an investment if the other players do not exist. So in Germany, we call that the Henne-Ei problem. Yes. So the egg and the hen, what is there first, the egg or the hen? And if you do not first have one solution and create a demand, and that's why mobility, emission-free mobility using hydrogen using fuel cells in cars can create a demand for renewable hydrogen, for green hydrogen. And then investors will come, build up electrolyzers, and sell this green hydrogen to the mobility solutions. And this path is now growing and is actually happening. And why are we talking about that here in northern Germany? Well, now that we've been talking about it, of course, here is the wind, right? So we need to find these solutions here. Coming back to the fuel cell, the electricity that is flowing here, the current depends on the size of your actual membrane, but the voltage depends on the technology, and that is between hydrogen and oxygen, 1.23 volts. So one of these cells produces 1 volt. So you put them all into series, and you have then such a stack of fuel cells, one membrane after another, and with that you produce enough voltage to drive a fuel cell electric car. This has been done since many years. So already in the year 1970, Professor Kordesch built his own fuel cell car. You see on the top, he put these hydrogen storage tanks, and that was just to show that you can drive a car with hydrogen. But at the World Hydrogen Energy Conference, one of the biggest hydrogen conferences in the world, already in 2004, there were a car by Mazda. There was a car by, what is that? Is that Mitsubishi, I would say. So these hydrogen cars are there, they exist, and they just need to be used now. In the year 2015, 2013, we had our first gas filling. We had the Hyundai and the Toyota there. These are the 2 cars that are now available in a series car. So you can buy this. Hyundai already has a second generation car that is now the Hyundai Nexo. It looks even nicer. Toyota also has the Mirai, but now it's Mirai generation 2. It still looks very similar, but everything under the hood basically has been exchanged. So these cars exist. You can just buy them. They are expensive. However, their technology is the same for a while now. So it looks like that in the inside of the car. Here you have your normal engine compartment. This is where the fuel cell sits. This is where your power electronics is. This is where your electric motor sits to go over a transmission onto the wheels. You have a bit of battery in the bottom of the car, but then in the back, you have your hydrogen storage tanks there in the back. So they lay there over the width of the car. This is even better seen here in this drawing. Opel was doing that. Daimler was doing that. Basically, everyone has already built hydrogen cars in their development. Why do we not see them on the roads? Why are there not even more hydrogen cars on the roads? Well, hydrogen cars have a big disadvantage, and that is they need to be filled on a hydrogen filling station. A battery electric car, you can just fill in any electrical plug. It takes forever, but okay, it works. A fast charger for an electric vehicle is way easier to build. For hydrogen, these filling stations cost about 1 million euros. There are a lot of hydrogen filling stations already in Germany and also all over Europe, especially Northern Europe. Again, they have been very futuristic, so to say, on that. They are a lot more innovative than we are in Germany. But Germany has about 100 hydrogen filling stations now. The money by the state is for 400 hydrogen filling stations. And we are now awaiting a lot more people to buy hydrogen cars now that these filling stations exist. And there will be individual people who have driving needs that cannot be fulfilled by battery electric vehicles. And time is running, and I have many more slides to show, but we are done with the main message. And the main message comes here. If we look at the different mobility solutions that we have all over the world, we can kind of show them on this graph. It shows on one axis the size of the vehicle that we are driving. So very small one. Here we have the scooters, here we have the motorcycles, then we go to small cars, and then here is like a container or cruise ship. And then on the other axis, we have the average mileage, right? How far does this mobility solution go? Is it only going 10 kilometers or 10 miles? It doesn't really matter. Or does it go bigger distances? Or as I said, if I'm driving to Schwerin and driving right back in one day, that is no problem, but it's a problem on the technology. So in this chart, we now see here the different cars, right? Or we see the small cars, we see the bigger cars, and the size of the bubble represents the energy consumption of this vehicle type. And you see that these medium to large cars are a big sector in the amount of energy that they consume. The solution that we see here in blue are the battery electric solutions. And I said earlier, right, we have good solutions for the battery electric vehicles, the small ones, the short trips. And then starting here in a certain range between green and blue, we have the medium to large cars. Then we start to go to transportation, into trucks, and suddenly the blue lines become very thin. There are certainly some trucks that could work entirely battery electric. And if they only drive short distances, if they have a defined driving cycle where they have the time planned for charging. However, if you have a commercial application for your vehicle, yes, your truck, your transportation unit, your taxi, every time that thing is standing around, you're losing money. So everything needs to be moving all the time. If you have a truck, you want that to be on the road and transporting goods and earning money for you. You don't want that truck to be standing on an electric charger for hours and hours and hours. So we need other solutions than the battery electric solutions. It does not work with only batteries. The thing now is everything that is done with a battery electric car can be done by hydrogen cars. Okay, so a hydrogen car can also drive the short distances. A hydrogen car can also stand for many weeks and hours, right? So everything that an electric car can do is something that the hydrogen car can do. So the question only is, if we have hydrogen available everywhere, and we will need the hydrogen because you cannot go across Atlantic with a cruise ship on batteries, that just simply does not work due to the reasons that I showed earlier, the volumetric and the gravimetric energy density. The ship has no space for passengers if it is driving with batteries. The cargo ship has no space for cargo if it's driving on batteries. Okay, so we need other solutions. And even hydrogen is not enough. And that is what this dark green region up here is. And we come here also, this dark green region with lines into the transportation sector with the trucks again. And that is hydrogen-based synthetic fuels. So we need to also talk about methanol. We need to talk about ammonia for the storage of hydrogen. And that's a totally different talk. And I can speak another hour about that as well. I'd rather have your opinion on that now. What do you think is it possible that we will see many different solutions in the future, or will there be one solution that will be so mainstream that there is no other solution available? And also, please feel free to ask your questions, because time is almost up and I don't want to start into another subject now. I hope I was able to convince you that hydrogen is a nice way to store our fluctuating renewable energies. The best solution right now is to give that hydrogen into mobility sector, because this is where we are willing to pay the highest price. It enables us to have an emission-free mobility. It gives us the option to keep our driving habits, right? Long distance driving, short refilling trips, and so on. Biofuel is the same. Biofuel and biodiesel. I have a strong opinion about that, and that is, as long as there are people hungry in this world, we should probably not take their food and drive cars and have a green consciousness from that. So it's an ethical problem. Do we have enough earth? Do we have enough ground where things are growing on to also drive our cars by energy plants? And the answer is basically no, right? I mean, we almost don't have enough ground to feed everyone. So that is a big problem. And also, we can use methanol from hydrogen in normal internal combustion engines and keep a lot of our infrastructure, so that would work as well. Of course, biofuel is a short-term greenish solution. However, it needs to be sustainable, and brings us to the title of this entire workshop, White Summer School. I mean, it has to be sustainable. And if we look at the fields that are used to produce biofuel, this has nothing to do with sustainable agriculture. Recycled food and so on. There are many ways, but they are way more expensive even. To produce biodiesel or bio oil from other biological waste, you need big infrastructures, and this is something that is expensive. It is possible, technically possible, has been done. However, the amount of energy that we need for our mobility solutions is huge. It really is. And the little pieces of bio oil that we produce, we should rather use for other things. For example, for synthetic clothing, for plastics. I mean, if I just look around, I see plastic everywhere, in my laptop, in my mouse, and everywhere there is plastic material. And so we should probably use the biological oil to produce in a sustainable way these plastic materials. Yes, a Tesla-like company would be nice. And I think without Tesla, we would not have battery electric vehicles in this broad application. To my knowledge, all car companies have had their research projects towards the different new solutions. Okay, they all had solutions for battery electric vehicles, and they all had solutions for fuel cell cars. Because I saw them at the different conferences, and we saw them at the different congresses, so it has been there for many years. However, they waited until someone really forced them into that pathway. And they weren't sure which path to take, the hydrogen electric vehicle or the battery electric vehicle. And they were waiting and waiting and waiting. And then Elon Musk emerged in the US and started the Tesla company, and everyone was laughing and saying, yeah, you do your thing, we will see. And then his selling numbers skyrocketed, and Tesla is now worth more than the other companies altogether. But that's going into the whole financing thing. If he would have done something with hydrogen, I think we would now have a hydrogen solution, because all the car companies would not have opened the drawer with the battery electric solutions, but they would have opened the drawer with the hydrogen solutions, right? And so if you are here to learn more, maybe more about these things, feel free to join our conference. You will find everything about the RECVA conference on the website of our university. Renewable energies and hydrogen, that is something that we will discuss again this year for the 28th time. We are discussing hydrogen and green solutions in Stralsund already since 28 years. We are proud of that, and we are willing to do that for many more years, not only with our students. So you can study that here in Stralsund as well. You can study renewable energies and electromobility, where we have such kind of lectures. We also have labs. I also invite you to our lab tour tomorrow, where I will show you how we, on a technical level, on a solution, I can show you then fuel cells again and everything through the camera. We have to see how that works. So please feel free to join our virtual tour tomorrow. Please feel free to come to the conference. It will also have an online part. And here you find our contact details. This is me, and Romy Sommer in the Institute for Renewable Energy Systems is also a good contact if you need to reach me. There's one more question. The urban mobility mix of the future, how will it be powered? I think it will partially be hydrogen, depending really on the future developments in the future developments in the battery development. We have to see how that goes. I'm pretty sure that we will see battery electric solutions, but as soon as we're talking about something like taxis, as soon as we're talking about future mobility solutions, right? I mean, I talked about the autonomous driving part. If I have a fleet of autonomous cars, of autonomous driving drones, where I can just jump in, right? I call them on my mobile phone. I say, look, I need to go from A to B, and I'm the owner of this fleet. What do I want? Do I want these drones to be at charging stations and waiting and waiting and waiting, or do I want these to be all the time on the road? If I want them to be on the road all the time earning money for me, then of course they need to have a different solution than battery electric. If the drone, if the car is cheap enough to have hundreds of them and allow myself to have them stand around for a long time and charge, then that would work as well. However, I'm pretty sure we will have a mix. We will have a mixture of battery electric vehicles, small vehicles in the urban centers. We will have hydrogen-based solutions for the mobility. So that is not only pure hydrogen in the car, but also methanol and or ammonia. We will have to see which one of these will decide for the bigger mobility solutions. Oh, I think autonomous underwater vehicles, that is a big other part. But also we have had projects there. We have had a very nice research project there towards using hydrogen there. In this case, we were developing a hydrogen station that charges a battery so that these autonomous underwater vehicles can recharge and go off. But that strongly depends on the application that you have in mind. So if that is something about, there are many military applications in this direction. And of course, there is transportation in this direction. And then there's a lot of science in this direction, using these little underwater vehicles for measuring things in the water. I think we have to stop because the next session will start at some stage.
Yeah, we've got 2 or 3 minutes, I think. So we're good on time.
Okay. I was just checking if the other one starts at past or no, we have
no,
to...
we've got a little break. But I did have a quick question. Well, maybe it's not a quick question, but I was wondering, because you mentioned that a hindrance currently is the expense of these hydrogen charging stations around the country. So that's one hindrance. Do you see any hindrances for sort of the widespread use of this technology from the consumer point of view? Is there anything that you're aware of that people are worried about safety or cost or anything like that?
Yeah, once you talk about hydrogen, people are always concerned about safety. I mean, they don't have to, because there are, as I said, series cars available. You can just drive them. You're allowed to drive them on German roads. So German TÜV looked at them. And so that is not a problem. The cost is a problem. Yes, these hydrogen cars are expensive, but then you drive green, right? And a lot of people are now willing to pay a bit more for a green consciousness. And so I think once we have enough filling stations, that more and more people will start to drive these cars. And the biggest hindrance I see is that our government, which we are now re-electing, right? Or not really, I mean, which we elect kind of, might have different ideas or different plans. And really, this is where a government can do what it's supposed to do. It can actually govern. And it can lead this in one direction or another direction. So the leadership that needs to be convinced of these solutions and not listen to maybe the manufacturing industry, where now, especially our German industry has invested a lot of money into battery electric vehicles. And probably this industry will tell our politicians, make laws that help us have battery electric vehicles and not hydrogen vehicles, because then again, Toyota and Hyundai will sell cars and not we. So yeah, that's one of the things where we really have to count on the politics. We will see how that works out. The technical solutions are there. That's what I was hoping to, or that's what I was presenting. And I hope that is what you learned. And if there are further questions, feel free to contact us.
That's fantastic. Thank you so much. Thank you all for being here. Almost 50 of you. That's brilliant. And thank you, Professor Gulden, for your talk. I think it was really interesting, and absolutely, the solutions are there. So let's put them into action. And yes, we should stop it here. And we've got about a 15-minute break before the next session starts. So I'll see all attendees there. And thank you again for being here and for your talk. And I hope it was very interesting to everyone. Thank you.
Yep, thank you for organizing everything and checking the technology. And so we will see you, most of you, hopefully again tomorrow in our lab tour.
Absolutely. Bye. Bye.